Before Ethereum, the blockchain world was already alive, but it was narrow. Bitcoin had proven that value could be sent over the internet without a central authority. It was revolutionary, elegant, and powerful. Yet, Bitcoin was intentionally limited. Its primary function was to be sound digital money. For many, that was enough. But for a few thinkers, it raised a deeper question. What if a blockchain could be more than just money? Among them was a young programmer named Vitalik Buterin. In 2013, while deep in the Bitcoin community, Vitalik saw the limits of a system that couldn't easily support complex applications. He imagined a blockchain that acted not just as a ledger, but as a global, decentralized computer. A system where developers could write programs that run exactly as coded, without censorship, downtime, or central interference. This idea became Ethereum. It wasn't created to replace Bitcoin, but to expand the very idea of what a blockchain could be. Instead of asking, how do we move money without banks? Ethereum asked, how do we build trustless systems for any kind of agreement or application? This shift would change the entire crypto industry. In late 2013, Vitalik released the first Ethereum whitepaper. It described a blockchain with a built-in programming language that would let developers create smart contracts, self-executing agreements enforced by code, not institutions. These contracts could represent anything from financial transactions to digital ownership. The paper quickly gained attention, attracting developers, cryptographers, and entrepreneurs worldwide. By 2014, the Ethereum project formally took shape. A core team was assembled, including Gavin Wood, who would later define the network's technical foundations. That same year, Ethereum launched one of the first and most influential initial coin offerings in crypto history. They sold Ether, the network's native token, to supporters who believed in the vision. At the time, this was controversial and experimental, but it gave Ethereum the resources to turn theory into reality. In July 2015, Ethereum officially went live with its first release, Frontier. This was not a polished product. It was intentionally raw, aimed at developers willing to experiment and push the network to its limits. There were no user-friendly interfaces, no polished wallets, and no mainstream attention. But beneath the surface, something profound was happening. For the first time, developers anywhere could deploy decentralized applications on a shared global infrastructure. As Ethereum matured, it entered the homestead phase in 2016, marking its transition from experimental to more stable and usable. Developers began building early decentralized applications, exploring everything from decentralized exchanges to prediction markets. The ecosystem was small, but momentum was growing. Then came one of the most defining moments in Ethereum's history. The DAO, short for Decentralized Autonomous Organization. The DAO was an ambitious experiment. It was designed as a decentralized venture capital fund, governed entirely by smart contracts and token holders. In a few weeks, the DAO raised over $150 million worth of Ether, making it the largest crowdfunding event the world had ever seen. But the experiment exposed a harsh reality. In June 2016, a vulnerability in the DAO's code was exploited, allowing an attacker to drain a huge portion of the funds. The Ethereum community faced an unprecedented dilemma. The blockchain had worked as programmed, but the outcome violated the community's sense of fairness and trust. The response split the community in two. One group argued that the blockchain must remain immutable, no matter what. Code is law, they said, and human intervention undermines decentralization. The other group believed that Ethereum was too young, and letting such a massive exploit stand would damage its future beyond repair. Ultimately, the majority chose to implement a hard fork to reverse the hack's effects. This decision created two separate blockchains: Ethereum, which implemented the fork, and Ethereum Classic, which preserved the original unaltered chain. The event was painful, controversial, and deeply philosophical. But it forced Ethereum to confront the real-world complexities of governance, ethics, and decentralization far earlier than most technologies ever do. And rather than destroying Ethereum, the crisis strengthened it. In the years that followed, Ethereum continued to evolve through a series of planned upgrades. These upgrades improved security, developer tools, and network efficiency. At the same time, Ethereum became the foundation for entirely new industries. The rise of initial coin offerings in 2017 was built almost entirely on Ethereum, using its ERC-20 token standard. While the ICO boom was chaotic and speculative, it proved Ethereum's unmatched flexibility and reach. Then came decentralized finance, or DeFi. Protocols for lending, borrowing, and trading emerged, all operating without traditional intermediaries. Soon after, non-fungible tokens, or NFTs, transformed how we think about digital ownership and creativity. Artists, developers, and communities found new ways to create and exchange value, once again using Ethereum as the base layer for innovation. Yet, as adoption surged, Ethereum's limitations became clear. Network congestion and high transaction fees highlighted the need for scalability. More importantly, its original consensus mechanism, proof of work, raised serious concerns about energy consumption and long-term sustainability. This set the stage for one of the most ambitious upgrades in blockchain history, the transition from proof of work to proof of stake. After years of research, testing, and development, Ethereum completed the merge in 2022. This fundamentally changed how the network reaches consensus. It wasn't a new blockchain, but a seamless transformation of the existing one, reducing energy consumption by around 99% and laying the groundwork for future scalability improvements. By this point, Ethereum was no longer just an experiment. It had become a living, evolving system, shaped not only by code but by philosophy, community debate, failure, and adaptation. And yet, understanding Ethereum's history is only the first step. To truly grasp why it matters, we must look beneath the surface into how it actually works, how it processes logic, enforces trust, and operates as a decentralized global computer. That is where the real story continues. Forget everything you think you know about Ethereum. Beyond the flashy headlines and dizzying price charts, there's something far more profound happening. To really get it, you have to stop thinking of Ethereum as just another cryptocurrency. Instead, imagine it for what it truly is, a decentralized world computer. Now, that might sound a bit abstract, but it's the key to everything. Unlike the computer on your desk or the servers owned by giant corporations, Ethereum isn't owned by anyone. It's a single shared system maintained by thousands of people all over the globe, all agreeing on the exact same state of affairs at any given moment. At its very core, Ethereum is what's called a state machine. Think of it like a universal ledger that keeps track of everything: account balances, the code for different applications, and all the data associated with them. Every single time a transaction happens, the state of this global computer changes. But here's the magic. It changes in a perfectly predictable, deterministic way. Every participant on the network independently checks and verifies these changes, making it impossible for any single person or group to cheat the system. This shared, single version of reality is what gives Ethereum its power. But what truly sets Ethereum apart from earlier blockchains like Bitcoin is its ability to run any kind of program you can imagine. This is all thanks to a brilliant piece of technology called the Ethereum Virtual Machine, or EVM for short. The EVM is a completely isolated, sandboxed runtime environment that exists on every single computer participating in the network. It's designed to be perfectly deterministic. That means if you give it the same input, it will always produce the exact same output, no matter where in the world it's running. This guarantees total consistency across the entire network. And inside this virtual machine live the famous smart contracts. These are programs, usually written in a language called Solidity, that get deployed directly onto the blockchain. Once they're there, they are completely immutable. They can't be changed, they can't be paused, and they can't be censored by any government or corporation. A smart contract will execute exactly as it was written, automatically, whenever it's called upon. This is Ethereum's greatest strength, but it's also a huge risk. A bug in the code is permanent and can lead to irreversible consequences. So how do you actually use this world computer? Every single interaction, whether you're sending some ether to a friend or using a decentralized application, starts with a transaction. You broadcast your transaction to the network, it gets validated by participants, and eventually it's included in a new block, becoming part of the permanent record. But unlike the internet you're used to, where using services is often free because you're the product, computation on Ethereum has a direct cost. This cost is managed by an ingenious internal pricing mechanism called gas. Think of gas as the fuel for the Ethereum network. Every operation a smart contract can perform, from simple addition to complex calculations, has a specific gas cost. When you send a transaction, you have to specify how much gas you're willing to use and what price you're willing to pay for each unit of gas. This system does three crucial things. First, it prevents spam by making it expensive to flood the network with useless transactions. Second, it compensates the people who run the network and keep it secure. And third, it efficiently allocates the network's limited computational resources to those who value them most. In essence, gas turns computation from a free-for-all into a structured economic activity, creating a beautiful alignment of incentives between users and the network's validators. For many years, Ethereum secured itself using a system called proof of work. You've probably heard of it in the context of Bitcoin mining. In this model, miners around the world would compete to solve incredibly difficult cryptographic puzzles, burning massive amounts of electricity to propose the next block of transactions. While proof of work was battle-tested and effective, it had some major downsides. The energy consumption was enormous, it couldn't scale very well, and the need for specialized, expensive hardware created a high barrier to entry for new participants. But the Ethereum community always had a different vision for the future, a plan that finally came to fruition with a historic upgrade known as the merge. With the merge, Ethereum transitioned to a new system called proof of stake. Under this model, the network isn't secured by miners burning energy, but by validators who lock up or stake their own ether as collateral. These validators are then randomly selected to propose and confirm new blocks. If they act honestly and follow the rules, they get rewarded with new ether, but if they act maliciously or even just negligent and offline, they can be penalized and lose a portion of their staked funds. This is a game changer. It fundamentally rewired Ethereum's economic and security model. Instead of security being tied to an external cost like electricity, it's now tied directly to the economic value within the system itself. To attack the network, you would need to control a huge amount of the total staked ether, making an attack not only ridiculously expensive, but also self-destructive, as you'd be destroying the value of the very asset you hold. A key component of this new architecture is the beacon chain. It acts as the coordinator for all the validators, managing the consensus process and ensuring something called finality. Finality is a critical property that guarantees once a transaction is confirmed, it can never be reversed or changed. This brings Ethereum much closer to the kind of rock-solid reliability you'd expect from global financial infrastructure, boosting trust and reducing uncertainty for everyone using the network. But even with the efficiency of proof of stake, Ethereum still faces one of its most persistent challenges: scalability. As more and more people use the network, it gets congested, just like a highway during rush hour. When too many users are competing for the limited space in each block, transaction fees, the gas prices we talked about, can skyrocket. This can price out smaller users and slow down widespread adoption. Ethereum's answer to this isn't to just try and make the main highway infinitely wide. Instead, its strategy is to build a whole ecosystem of layered scalability solutions on top of it. This is where you hear terms like Layer 2 South. Layer 2 networks are separate blockchains that operate on top of Ethereum, inheriting its powerful security guarantees while handling transactions off the main chain. Technologies like optimistic rollups and zero-knowledge rollups are at the forefront of this. They can bundle thousands of individual transactions together into a single, compressed piece of data that is then posted back to the main Ethereum chain. This drastically increases transaction throughput and slashes costs for users, sometimes by a factor of 100 or more, all without sacrificing the decentralization and security of the base layer. Ethereum doesn't see these Layer 2 South as temporary fixes or competitors. It embraces them as a core part of its long-term roadmap. The vision is for the main Ethereum chain, Layer 1, to be the ultimate settlement layer, focusing on maximum security and decentralization. Meanwhile, Layer 2 South handled the bulk of user activity, providing the speed and low costs needed for everyday applications. It has a modular approach that reflects a very deliberate philosophical choice: prioritize long-term resilience and decentralization over chasing short-term performance metrics. Another architectural superpower of Ethereum is composability. Smart contracts are like digital Lego blocks. They are designed to interact with each other seamlessly. This allows developers to build incredibly complex and powerful applications by snapping together existing, pre-audited components. This composability has led to an explosion of innovation, especially in the world of decentralized finance or DeFi. You see lending platforms that integrate with decentralized exchanges, which in turn integrate with yield-generating protocols, all operating in perfect harmony without any central coordinator. It's a dynamic, open ecosystem where innovation can build on itself at a breathtaking pace. Of course, this powerful feature also comes with systemic risks. Because all these protocols are so deeply interconnected, a failure in one can cascade and cause problems for many others. A single bug or a clever exploit in one smart contract can have widespread consequences. The open, permissionless nature of Ethereum means that innovation often moves faster than security best practices can keep up. Managing this tension between rapid, open experimentation and ensuring the stability of the entire system is an ongoing challenge for the entire community. Despite these complexities, Ethereum continues to evolve through a clear and carefully planned roadmap. Future upgrades are already in the works to further improve scalability, reduce data costs for Layer 2 South, and enhance the overall user experience. An upgrade known as sharding, for example, promises to be another massive step forward, allowing the network to process data in parallel, almost like creating multiple lanes on the main highway, which will support an even larger and more vibrant Layer 2 ecosystem. When you take a step back and look at Ethereum's design as a whole, you realize it's not about being the fastest or the cheapest at any cost. It's about creating a credibly neutral, open, and censorship-resistant foundation that anyone in the world can build upon. Every design decision, from the EVM to gas to the embrace of Layer 2 South, represents a delicate and deliberate balance between the three core pillars of the blockchain trilemma: decentralization, security, and scalability. Understanding this architecture is what reveals why Ethereum has become the undisputed backbone of Web3. It's not just about raw performance. It's that it is more adaptable, more expressive, and more deeply committed to the principle of decentralization than any other platform. And yet, brilliant technology alone is not enough to guarantee success. Ethereum's true power lies not just in its elegant architecture, but in the incredible global ecosystem that has grown around it, the immense economic gravity it has accumulated, and the boundless possibilities it continues to unlock for our digital future. To truly see where Ethereum is headed next, we need to look beyond the code and examine the internal strengths and long-term potential it holds in our rapidly changing world. What is Ethereum's true strength? To really get it, you have to look past the code, past the buzzwords, and see the massive ecosystem it's built. Technologies come and go, but platforms that pull in developers, money, and a shared belief, those are the ones that stick around. Ethereum's biggest asset isn't just one single feature. It's the incredible network effect it's built over years. Millions of developers, users, and even big institutions have made Ethereum their home base, creating a system that gets stronger and more valuable with every new person who joins. At the heart of this strength is the developer community. Seriously, no other blockchain has attracted such a talented and dedicated army of builders. You have solo coders in their basements dreaming up the next big thing, and you have huge teams building the future of finance. Ethereum has become the go-to place for decentralized innovation. This didn't happen by accident. The tools, the documentation, and the whole culture of openness have made it easy for anyone to jump in and start creating. And every time a new, successful app launches, it just pulls in more talent and more money, making the whole ecosystem even more powerful. Decentralized finance, or DeFi, is probably the clearest example of what Ethereum can do. On Ethereum, financial services are just software. Lending, borrowing, trading, it all happens without banks or brokers. These systems are completely transparent, available to anyone in the world, and they all work together like Lego bricks. Anyone with an internet connection can use them, no matter where they live or who they are. Now, DeFi isn't perfect, it's still finding its feet. But it has proven that a totally different kind of financial system is not just possible, it's already working. Then came NFTs, which blew the doors open even further. NFTs completely changed what it means to own something online. Suddenly, artists, musicians, and creators could prove that their digital work was the original, creating real value and scarcity in a world of endless copies. And while the early days were all about speculative art, the real idea is so much bigger. We can turn anything into a token real estate, intellectual property, even our own identities. Ethereum's flexibility makes it the perfect foundation for this massive shift in how we think about ownership. Ethereum has also given us brand new ways to organize ourselves with something called DAOs, or decentralized autonomous organizations. Think of them as internet-native companies or communities that are owned and run by their members, not by a CEO or a board of directors. Decisions are made collectively, through code. It's a radical idea that challenges our traditional corporate structures. While these are still experiments, they show us that organizations can live entirely on the internet, governed by the people who participate in them. Ethereum is the backbone that makes these incredible social experiments possible. But let's be real, Ethereum isn't without its problems. We've all heard about the crazy high transaction fees when the network gets busy. It's a real roadblock for everyday use. And while solutions called Layer 2 South are making things cheaper and faster, the experience can still feel a bit clunky, especially if you're new to crypto. Security is another huge challenge. Smart contracts are powerful, but a single mistake in the code can lead to devastating losses, and we've seen that happen. And of course, the competition is heating up. New blockchains are popping up all the time, promising to be faster, cheaper, and easier to use. Some of them achieve this by cutting corners on decentralization, making them less secure and more controlled. Others just struggle to get anyone to actually use them. Ethereum's strategy has always been different. It's more conservative, prioritizing security and long-term stability over flashy short-term speed. It might seem slow, but it's a marathon, not a sprint. Then there's the big question of regulation. As Ethereum starts to interact more with the traditional financial world, governments are taking notice. There are still a lot of unanswered questions about taxes, compliance, and legal responsibility. But regulation isn't necessarily a bad thing. Clear, smart rules could actually bring more legitimacy to the space and help bring crypto into the mainstream. And because Ethereum is so open and transparent, it's in a great position to work with regulators to build a sensible framework for the future. So what does that future look like? Ethereum's roadmap points to a world of modular scalability. Things like sharding will eventually allow the network to handle way more transactions, supporting a huge ecosystem of fast and cheap Layer 2 South. We're also seeing the rise of zero-knowledge technology, which will not only boost speed but also bring a new level of privacy. The end goal is for you to use Ethereum-based apps without even knowing you on a blockchain. All the complexity will be hidden behind simple, intuitive interfaces. Beyond the tech upgrades, Ethereum is positioning itself to be the neutral settlement layer for the entire digital economy. Big banks are already using it for tokenized assets and stablecoins. Governments are exploring it for things like digital identity. As AI, the Internet of Things, and decentralized networks all start to merge, Ethereum could become the fundamental trust layer that allows all these different systems to communicate and transact securely. But maybe the most important thing about Ethereum is the change in mindset it represents. It challenges the old idea that we need big, centralized companies or governments to trust each other. It questions the need for rigid hierarchies to get things done. It offers a new way to think about ownership, governance, and how we create value in a digital world. Ethereum doesn't have all the answers, but it gives us a powerful new set of tools to find them. Will Ethereum achieve everything it set out to do? Nobody knows for sure. History shows us that game-changing technologies rarely turn out exactly as planned. They're shaped by people, by culture, and by unexpected events. But what is certain is that Ethereum has already changed the conversation forever. It has shown us what is possible with blockchain and has inspired a whole generation of builders to dream of a more open, transparent, and inclusive world. In the end, Ethereum isn't just a bunch of computers and code. It's a massive, ongoing experiment in global, decentralized coordination. Its success won't just depend on technical upgrades. It will depend on the people who build on it, use it, and believe in it. And in that sense, the future of Ethereum is still being written one block, one idea, and one community at a time.